Exercise 15.5 says for each pair of compounds, determine which carbon-to-carbon bond, double bond, will produce a stronger signal. And the strength of the signal is how far the dip goes down in the IR spectrum. So from weakest to strongest, you'd have a dip like this, and a dip like this, and a dip like that in your IR spectrum. So this is the stronger signal there. Now, those are shadows, right? This is percent transmittance, how much light it gets through the molecule. And so when you have a dip that's really low, that means very little light, only like maybe 10% of it, is transmitted through it. It gets through the molecule. So you're really casting a shadow there. And bonds will only cast shadows if you shine infrared light on them. They'll only cast shadows if the bond has a dipole. If you have a bond like the bond in molecular hydrogen, these two hydrogens are equally electronegative, and so they share these electrons perfectly equally. There is no partial charge on these hydrogens. So when a wave of electricity meets this, it doesn't meet any electricity. It doesn't meet any electricity in the molecule, and so it just travels right through it. And hydrogen gas is clear. Compare that, though, with something like, something that had a dipole. So let's say, I don't know, carbon monoxide. In this molecule, the oxygen is slightly negative, the carbon is slightly positive. And when you shine light on this, a wave of light on this, now when the electricity runs into this, it starts interacting with these charges. And those charges sort of absorb the electricity, and instead of letting it go through, it responds to them in the bond, and the bond vibrates. So in other words, for a bond to cast a shadow, you have to have a dipole. You have to have a slight positive and slight negative charge in the two atoms in the bond. The bigger those charges, the deeper the dipole. In other words, the stronger the signal. So in this question, when they're asking you which of these molecules is going to produce a stronger signal, you're really looking for the one with the bigger dipole. So notice this, if you sort of cut this molecule in half, neither side, neither the left nor the right, really has an electronegative element on it. It's not perfectly symmetrical, so it does have a tiny, tiny dipole, so it may interact with light a little bit, but nothing big, nothing major, nothing very electronegative. Compare that with this molecule on the right. Look at the left and right half of that. Oops. So here we have the left and the right. So on the left, we don't really have any very electronegative atoms. On the right, we have a chlorine, though. And so in general, this molecule will have a slightly negative charge on the left side and a slightly positive charge on the right side. And that means that this molecule on the right will interact with electricity, waves of electricity, will interact with light more strongly. So this would cast the stronger shadow, whereas this one might just cast a weak shadow. This would cast the stronger shadow and give you a stronger signal. Why? Because it has a bigger dipole. Bigger dipole. So it would be that molecule there. We could play the same sort of game with B. Look at the left and right half. You have a pretty electronegative atom there on the left, pretty electronegative atom there on the right, but they pull against each other, and so it's sort of like a tug of war where you have strong people on both sides, but they're equally strong on both sides, so neither side really has a strong charge. Compare that with the other molecule. Put a line down the double bond there. Here you have two chlorines on the left. They're both electronegative, they both work together to pull electrons to the left side of that molecule. On the right side of the molecule, will be slightly positive on the whole. And so because this has a bigger dipole, it will interact with waves of electricity better. The electricity will feel those charges more. And when it interacts with that light, the light gets absorbed, and you get those dips in the IR spectrum. So this molecule on the right with the bigger dipole will give you the stronger signal. So the take-home message here is bigger dipole equals stronger signal. And a stronger signal is just one that dips down further, casts a bigger shadow.